atmosphere, and they'll still deny it.
So the premise of LIGO is general relativity, right? Like gravity waves.
Their measuring device is shooting a 4-kilometer long laser beam down a vacuum tube.
Real
So
quick,
there's no atmospheric refraction.
Okay, so look, that's fine. We can't prove the Earth is curving because you can't show that the horizon is of a physical nature, Charlie. So we have to put that one to bed.
But back to the point that was just being made. The thing with LIGO is the construction of the vacuum tubes, which, universities, MIT, Stanford, all of them get right up there and talk about the tangency of the triangle of the two tubes being tangent to a point of the Earth somewhere inside that triangle. Now, this is MIT, and then you get the crap heads like Witsit and Chemo saying, or Bev, or Mabbott, or Jeremy, or Cleary get up there and say, this is all fake, it's all fabricated. So, to your point, yes, these people say that they are so confident in their assertions that MIT and Stanford is wrong. That's how
that's a natural thing that's going to happen. Before, we were fairly certain in our uncertainty, where we couldn't trust our senses that told us it was flat. Now that we're trusting our senses, we're even more certain than before. It's just a natural byproduct of the progression.
And Lemon, you're one of the worst because you surround yourself with technology and then hate all the academics and technology and physics that brought you the technology you use.
They can still work on a flat plane.
No, because a flat plane defies physics.
What do you mean? The Neoplatonic declaration by you and others that gravity pulls stuff into a ball? What bases that? Nothing.
Observation.
Lemon.
Observation is the starting point to start your exploration. And you know what we found after 500 years? Nothing.
Hold on.
Curvature and no things that are clumping together into balls due to gravity.
So, and Lemon has just reinforced my point.
I have Charlie, the Neoplatonic assumption that gravity pulls stuff into balls. You can't do it. Sorry.
Well, maybe Lemon, that Charlie can help us with that. We'll probably get to that point in just a second. So, Charlie, the idea is that we live in a gas pressure. Yeah.
What?
The atmosphere is pressurized with gas. Yeah.
Charlie was about to say
pressurized.
Something?
It's not that it's pressurized. It's that pressure is an emergent property of any fluid.
Okay. So,
and space itself is a fluid, an ether that could give us this pressure and these gravity waves that they incorrectly ascribe to Newton and stuff like that.
Wait. You subscribe to the luminiferous ether?
Hell yes, flowing over a flat plane.
So what do you think of the Michelson Morley experiment?
Whoa! But that's what we're gonna get questioned. Hold on, Lemon. Let's look at their model.
Did we say this before?
Yeah, but Lemon.
Don't get Lemon.
Let's look at their model, which tells us the atmosphere is under pressure. And we know, Charlie, that you cannot have gas pressure without a container. So how do you...
That's not true. That's not true.
That's what I'm going to ask.
So here's the thing. You can have pressure... Okay, so pressure... This I can actually explain to a 5-year-old. It's very simple. Okay. If you believe in the existence of atoms and molecules, which I presume you do you?
No, there's no assumptions will be made, Charlie. We're going to just look for the real...
You don't believe in atoms?
For your final point. Please make your final point. How do you have pressure without something to press against?
What? What are you talking about?
So first of all,
normally you have to have something to press against.
Do you understand that pressure is just a force distributed throughout an area? And that a force
without anything to press against, you have no pressure.
Hold on, let me finish. The force, all that a force is an exchange of momentum per time. In fact, that's how we define force, the derivative of momentum per time. When you have two balls that collide, or a ball, in this case an atom, hitting against the surface, it's exchanging momentum with that surface. Okay? and that
I'm just talking about
experiences a
your
force.
mod. I'm just talking
So
about.
hold on. I swear, I asked you give me like 1 minute uninterrupted. Okay. The way that pressure emerges, if you can imagine a piston, right, that has like a piston head and it's a cylinder, and you fill it with a gas, because the gas has a temperature, you can imagine it as a bunch of really tiny tennis balls bouncing around the container, and they don't lose any energy, right? They keep going. They hit the top of the container, the bottom, and the piston. Whenever they hit the piston,
the problem, you need a firmament to hold the pressure in.
Please let me finish. Please let me finish. Whenever the molecules hit the piston feels an upward motion. Okay, and because atoms and molecules are extremely tiny, on average, you can say there's an average force per unit area on the piston, and that's what we call pressure. Notice that the container is actually not necessary in this. You could just have the cylinder disappear and have a bunch of molecules that are hitting against.
Are you talking about an
the piston.
engine? An engine isn't closed, so that doesn't even go with what you're saying.
I'm not talking about an engine.
Going back to what we were saying, you need to have a firmament dome to keep the pressure in. That's why you're speaking around the problem. You're not dealing with the fact that we have atmospheric pressure, which would tend to make one conclude that we're in a firmamental containment of some sort.
Do you know what a light sail is?
Around the problem.
Do you know what a light sail is?
We're talking about a piston and a cylinder, and it wasn't an engine you were talking about.
Brian, go fuck yourself. I hate you, and you're a retard. Anyway, so
if you're just going to speak around the problem, we have nothing to say. To have atmospheric pressure, you need to have a firmamental dome container. That's it. Speak around that.
No, you don't need. You don't need a container at all. All you need to do is to have an exchange of momentum from the particles that make up the fluid, and whatever object it is we're talking about is getting pushed.
Okay, so this is all very nice, Lemon and Charlie, but again, what I'm looking for, Charlie, is the science. Okay, the science that supports that you can have gas pressure without a container. Okay.
Okay.
I'm looking for the science.
For example, the atmosphere. For example, the atmosphere of the Earth.
Yeah.
There's no container. There's no container in it.
Right.
Around it.
Yeah. That's what we're saying. So the claim is.
But we still feel pressure.
Yeah, but your claim. Charlie, listen to my words. I'm looking for the science to support the claim that we can have gas pressure without a container.
Again, by construction, I just showed you how.
Did you hear what was the first thing I said?
You did not.
You were asking me for the science that shows. You're asking me for the science that shows that you can have pressure without a container, and I just gave you a proof by construction, right?
Okay, that's the claim.
You constructed a piston which is contained in an engine. You didn't address the problem. You need to show an engine that isn't contained.
Then he wasn't talking about an engine with a piston and cylinder.
Brian, go fuck yourself. So again,
there are five pistons and cylinders than an engine. What are you talking about?
Complete and utter nonsense.
Go fuck yourself, you retard. Anyway, so what I was saying is that pressure is an emergent property of a bunch of molecules and atoms bouncing together with a certain temperature. That's what pressure is.
Charlie, I'm not arguing that. I understand.
Charlie,
you
I tried to
understand.
explain to him like a million times.
And if you understand that's what pressure is, you see that you don't need a container for it to happen.
Okay.
Charlie,
Just explain to you why.
I know you're giving me the explanation.
Fucking complete.
Guys, what's going on?
Pressure would dissipate without containment, so what you say is irrelevant. Zanuck, what were you saying?
Zanuck's about to back y'all up.
Let me make a point real quick to Charlie. So Charlie, we've gone over this a million times about we talked about the change in momentum, that being a force, and that force of areas of pressure. And we don't need these Gaussian collisions to be in a container. It can be with each other. And they go, oh, they don't show me that in life, show me this, that, and the other. We say, okay, just weigh something. Weigh a container of air. Why does it have weight? How does that? How do those molecules or the atoms? Hold on, let me finish. Why do those molecules?
But what we're trying to do is ask Charlie what he knows about gas pressure.
Would you let me finish to Charlie? I'm talking to Charlie for a second.
You just interrupted.
10 seconds in.
Asking for the science that proves the claim, and he said,
Zanuck.
Chemo, why do this?
Because I was in the middle of a conversation.
I know, but you've heard him get halfway through it, and then you've decided, after him talking for about 30 seconds, oh no, we're going to just stop this now. And while you're doing that, have an argument about stopping it. Why don't you just let him finish?
Why didn't he let me finish?
He would have been done by now.
Because I was already talking.
No, I asked him a question and he was responding.
I wanted to make a point to Charlie because Charlie's trying to explain to you how pressure works.
Well, exactly. So I'm not asking you your opinion. I want Charlie's version.
This would be Charlie and me because he's new here.
All right,
I'll give you a little background on you guys not understanding how this container with pressure actually registers.
But that's the idea, Zanik. They want somebody new, so that
I know,
they're not.
but I was
they're not all saying the same crap that you do.
I know, but I wanted to give Charlie.
Yeah, but we don't need Zanik. You to get involved in how Charlie. If he gets it wrong afterwards, then explain to him.
No, I wanted to give him a little color.
Well, he doesn't need
that right now. It would have been done already a long time ago. It was literally 30 seconds of a comment.
It doesn't matter. What we want to hear is from Charlie. Charlie's a big boy. Okay.
I know. I'm not trying to argue with him. I'm just talking to him, the new guy.
All right, just leave it now, Zanik. Thanks. I think you made your point. Go ahead, Keema.
Charlie, again. Okay, I heard your explanation. I'm looking for the science, which means experiment.
That is science. That is science.
I need a dependent variable, Charlie. I need one. I'm just stupid without it.
Dependent variable, boy. Charlie, talk about why a container of gas has weight. That might be an easy way for them to understand.
Why the container has weight or the gas itself?
The gas, how you can register weight of this gas, if it's going in all direction, why does it have a downward vector? Ask them that, and maybe they can get a better grasp of what's going on.
You're asking me how a gas can have weight? Because gravity is still affecting all these molecules.
Look what's happening. They're going to have a back and forth for the next 15 minutes explaining how he's wrong and how gravity... And Zanik should say this, maybe we should say that, maybe we should say...
Go in all directions, Zanik.
This is the point.
This conversation. Fine, hold on.
The velocity is downward.
Here we go, just like I said.
On the bottom than the top. That's how it registers
weight. Prove it.
Hey, Charlie, keep talking about gravity.
Excuse me? Keep talking about gravity?
We will lose our shit. Please
are we done talking? Are we done talking about pressure then, and how you can have pressure without a container?
No, you can't have
gravity.
Pressure without a container.
Gravity is why we have
gravity is the bending of space-time as we know it.
Why does the container register more weight when it has gas in it? If it's going in all directions evenly, why is the tank of gas have weight?
Again, because all of the molecules inside the container are still subject to gravity.
And how does that affect them?
What do you mean, how does it affect them? The same way it affects everything.
I'm on your side on this, by the way, because why are we're registering a greater pressure on the bottom? That's how it has weight.
Yes. So yes, you're right. So okay, I get what you're trying to get me to go. So gravity is affecting the molecules as they're flying, and as they're flying, they're picking up more and more downward velocity, resulting in a higher net pressure at the bottom of the container. Wait, no, that's not right. Let me think about this.
The greater force at the container.
Is that right?
The velocity's
Charlie,
greater.
I'm starting to like
so when it hits the container, it's greater, and that's how you register the force on the scale. Because gravity has taken the gas and actually made it go faster only on the way down.
There's also other reasons, but yes, that is a contributing factor. One that's actually really fun that I learned about, reading the Feynman lectures, is that anything that has energy has mass as an emergent property. So if you actually have a gas under pressure, it has more mass than if it were not under pressure.
You just said a light was mass. They're going to chew your head off in here, dude. They don't like that. They do not like that, Charlie. You got to know what side. They say they're on your side, and then they're going to jump down your throat the next minute, man.
You got to
there's nothing wrong with doubting what I say or taking stuff back.
But barometric pressure is a product of gravity and the gases of the atmosphere, and that's where chemo is going to blow up.
Gravity is the bending of space-time, isn't it?
And then with the cause rather than the effect. Okay, go ahead, Brian. Talk about the cause rather than the effect.
I think Charlie's starting to see through you all already.
How do we know it's strong enough, this gravity, to hold down the air? What if gas is moving apart?
No, it's the weakest force there is, apparently.
Compared to what, Brian?
Compared to the rest of the forces on Earth.
Show me a magnet. Show me a magnet.
That's why an apple will fall from a tree, and then if you put it under water, it goes upwards.
Is that why,
That's your
Brian?
gravity for you.
Really? It's not pulling the other things greater than the apple?
No, the apple He's
why would it
obviously
have
less dense than the
why
water.
would it have why
but
would
it's
it suddenly
obviously
see,
more dense than
why-
the air. Don't
Brian,
interrupt, Sonny. Don't interrupt,
why would
please.
why would it have a
Interrupt.
preference
I was
to the
talking.
apple rather than the water around it?
The apple is more dense than the air, so it will try and find its equilibrium.
more weight.
But it's less dense than the water,
So the water
it tries
has more
to
weight.
find
You
its
can weigh that water.
equilibrium.
You
It
can weigh
goes
that water.
upwards.
Pulling.
Guys,
There is no
please,
such thing
guys,
as gravity.
guys, hello. Please
Hello.
please make the effort not to talk over each other. It's
It
impossible for
weren't
anyone
me,
to.
it was him.
It's both of you.
No, it was not.
It is
Then
both
why
of
does
you
pulling
doing
more-
it constantly. Please stop
Sorry,
it.
sorry. Why does pulling more equal stronger buoyant force, but
Fucking
the
gravity
same
cause
falling
gravity.
acceleration rate? in vacuum?
Brian, you're doing it.
I'm
I
just
didn't do
telling
it.
you,
You're
I
doing
forget.
it. Brian, just
Get
shut
back
up for a
to science,
second.
man. Danik, get
I'm
back to
building a
science.
drone.
No, I'm trying to defend you. He keeps on talking.
Yeah, but, okay, so why does the buoyant force trump the, let's say, the rate of fall? As we know, different size and dense objects fall at the same rate. So why does it get, why is that, and then yet to the buoyant point you made, it's pulling more, pulling the water more than the apple.
You're asking,
I don't
are you
think they
asking
are.
why
It
is
has more
buoyancy
weight.
I think
are you asking why is buoyancy stronger than gravity? It's not in general.
no,
It's just
no, no,
most
no,
of
no,
the case it
no.
is.
Hey, what
No,
do you
no.
mean it's not? How does a boat float then?
Why is the acceleration rate the same if there's more gravity force on a denser thing?
Oh, that's easy. I actually answered this question on Reddit because for more massive things, you need a greater force to achieve the same acceleration. Like the common thing across all the objects on Earth, or at least to a great approximation, is that they have constant acceleration downwards. What that resulting force depends on the mass, right? If all objects have the same acceleration, then for a more massive force, you need greater force to achieve the same acceleration.
So it's
Boy, you've got to learn,
visualized,
Charlie.
or it's realized when they touch each other. In a vacuum, it's not realized, but then when they're relative to each other, then that's when it manifests.
I have no idea what you just said.
No, nor is
Well,
he.
they're
Don't
equal
worry.
in space. Things falling are equal
Don.
in space, but you're saying there's more potential in the denser one.
Don, we already went over this a million
Yes,
times
there's
as
more
well.
gravitational potential on the other one at the same height. Yes. Wait, no. Gravitational potential is independent of mass. Sorry, just like
Kinetic? Is it
just like
kinetic
electric
then?
potential.
Okay,
No.
so
Okay, so do you agree there's a difference between electric potential and then potential energy, right? Like one
no, I'm
is
not
proportional.
smart enough to talk like this. I'm not smart enough to talk like this.
Oh.
What I'm saying is like everything is equal, but there's more. Like your explanation was great. You're like there's a heavier thing, it has more gravity affecting it, but the fall rate is similar because of the balance of those two things. That's a great explanation. But now
Don,
we're talking about when those things get into.
Don, we already
contact
said
with
that
each
force
other,
is proportional to the mass.
Thanks,
We've already
thanks.
talked about that.
Hey, let him
Same
answer this
acceleration.
question. Let him answer this question real quick, though.
Yeah, so they fall at the same rate. You talked about how there's more in the denser thing. There's more whatever.
More
It's balanced
force.
because
Don't just say whatever. It's
Yeah, yeah.
important. It's important for you to be precise in what you're saying.
I can't. Sorry, help me though. Help me.
Don, you can. Bigger mass,
Okay.
more force, same acceleration. We know that. They're related. They're directly proportional.
So right. So
You have,
then,
remember we
though,
talked about the
then if it's
table and the
obvious
1 kilogram
when
and the
they're
1 meter per second squared.
Xanax.
We all know that if you have a same acceleration, if you increase the mass, you got to increase the force.
Xanax.
That's
I mean,
what
we
he's
all
ask,
get it.
he's
We all
asking this
kind of get
question,
it. I
man.
just want to, I want to talk through why more, like the mechanics of it. I get the rules.
I mean, I
just
can.
told you the mechanics.
The math is very easy. Do you want me to show it to you?
No, if you could just talk about it.
Okay, so the definition, I think most people don't understand what mass actually is. They just think it's this quantity that you measure and then it tells you how heavy stuff is. When in reality, mass is more clearly defined as objects' resistance to a force exerted on them, right? Something that has more mass resists more to changes in its velocity. That's why it's better to call it like inertia. Mass is inertia. It means it's resistance to change. If something is bigger, it generally has more inertia. You need more force to prevent it from to
So
change
if
it.
it resists
Has
to
that
change
been its
more,
weight?
Brian, if it resists to change more, why does the apple come? Why does it get pulled under the apple then? If it resists change more. Water. Why would water get pulled under the apple?
The buoyant force, right? The buoyant force has to do with the weight of the object and the weight of the medium, right?
So buoyant force is the trump card. Buoyant force is the trump card then.
No, buoyant force is the difference between the weight of the object and the weight of the medium. If the weight of the object is heavier than the weight of the medium, then it falls. And we can calculate the force.
But
if
why?
the weight of the medium, is heavier than the apple, which it is, then it will have a force up on the apple.
Okay. I bet you're going to give me some numbers that can work
so many times ad nauseum, Don. And you know that we talked about the mass, the 1 kilogram mass, the 1 Newton force, the 1 meter per second squared. We know that he said it precisely. It's resistance to acceleration. It's resistance to change of velocity.
Ignorant kindergartner, Zanuck. Stop.
We're talking to you that way. Don't you get it? We are talking to you like you're an ignorant kindergartner, and you still don't get it.
That's the point, Zanuck. At some point, you have to take responsibility to understand. I'm a grown-ass man posing as a kindergartner. You know I can understand simple points. So if you're not able to get
the water weighs more than a beach ball?
You got to take responsibility, man.
Don, you're a grown-ass man, right? So you know when I push a beach ball underwater, what happens?
Well,
it goes up,
I'm guessing the water has more force acting on it, so the beach ball goes up because water gets pulled under it.
So I can tell you what's happening. Okay.
The weight of the water in volume compared to the volume of water, same as the beach ball, is more dense.
Adam,
it is heavier.
Hold on. No. I don't like this picture because I think there's a simpler picture, and it is the picture of
you just said it right.
molecules. If you believe that molecules exist, then what water really is this collection of little balls that are really touching up against each other. They're sort of sticky, but they're sort of shaking and they're sort of like sliding past each other and stuff. Okay? And so like whenever they hit each other, they exchange like velocities a little bit, right? And however violent they shake, that is what their temperature is. That's what it means for something to have a temperature. Now, if you put a big ball inside of it, right? There's going to be stuff that's shaking underneath it and stuff that's shaking above it. The stuff that's shaking underneath it is going to be shaking a little bit more violently than the stuff that's shaking above it. Why? Because the water beneath has to bear the weight of the water above it all, and so in general, it you could think of it as it slightly increases its movement, right? So on average, you have a higher push up than push down at the top of the ball, and that's what buoyancy is. That's what it is.
Okay, that's what flat earthers want to talk about. They want to talk about the pressure of the medium of space instead of this pull to the center of a ball like gravity, which was discarded with Newton years ago.
Let's talk about.
I think the way Don said it was just fine.
Let's talk about
perfectly fine.
The reason that I prefer my explanation is because if we talk about the pressure of nothing, you don't have a fluid. There's nothing to be buoyant against.
That's predicated on space being a substance with no properties. That was abandoned with the quantum vacuum, which is full of energy. And if it's full of energies, it probably has properties and is giving us gravimetric effects as space itself, the ether, is flowing around.
Yes, you're right. But that requires, for a buoyant effect to happen, you require a difference in pressure across distances, of which we have not observed at all.
Yes, we observe vacuum, quote-unquote, suction. We make a purified vacuum, and the moment we break that seal, stuff rushes in like it's elastically sticking to space.
Yes. Do you know what it does?
A space object into the vacuum.
Do you know why that happens? Because it seems to me that you don't.
You say that there's nothing in the vacuum to suck, so you have to say that everything is pushing stuff into the vacuum. I challenge that vacuum on its face. I say that the vacuum has properties, elastic properties,
right.
energy.
Hold on, you're saying multiple things here.
And
you're saying multiple things here.
Into it.
Hold on. Do you think that when you use like a vacuum cleaner, for example, do you really think it's actually sucking, or do you think it's more accurate to think that you're decreasing the pressure closest to the vacuum cleaner, and therefore the higher pressure outside the vacuum cleaner is pushing stuff in? Which is more accurate?
I'm challenging the theory that you're predicating your stuff off of. You say a vacuum can't have anything in there to act. I challenge that entirely.
Not for buoyancy, right? I agree with you that vacuum is not empty, right? There's energy in there. There's particles popping in and out of existence. But in order for that to display the concept of buoyancy, you need a delta. You need a difference in the condition. And as far as we know, the energy density throughout space is constant. That's why it's called the cosmological constant. It does not change throughout space.
I don't know. I think we need to challenge this stuff. I think the vacuum is purified ether, and we have the waters above the firmament, and we really need to look at this science from the waters above, from the vacuum ether. All of this stuff needs to be re-examined.
Because it's not actually uniform in space without dark matter. So thank you.
It looks like a fluid, a big energetic fluid.
The Milky Way is not reconcilable without conjuring something that's totally theoretical at this point. Thank you.
I know that us flatties can be a bit of a dick, but the thing is, you need a certain amount of zealotry to protect your brain and your mind from these lies. After you find out you've been lied to by Copernicans for 500 years, you're a little pissed. There's a little bit of red pill rage, a little bit of red pill arrogance, but we can talk about this like normal people without being dicks about it.
Here.
Well, I mean, there's nothing to talk to you about at all. You deny everything and have made up your own crap.
Well, the only person who was flexible enough to change their mind was me. So, I don't know what you're talking about.
He's right, He's right. You make up everything. It's actually entertaining, but it's getting old.
Well, the alternative is waiting for people to think for me for another 500 years.
Hit them with dark matter, Lemon. They make up everything. Everything is made up until the next level.
I think what's funny is that you're right to doubt things, but the level at which you doubt things is so inaccurate. Like, you don't even believe the basic stuff that everybody agrees on. The stuff that's in contention is so many layers and layers removed from what you're aware of and understand that you really have no ground basis to doubt the foundations of physics.
Well, maybe we gotta check the foundation of that. You talked about an atom, but we don't see all of the pieces of the atom. We see a generalized center and a hazy cloud around it. That's about the end of our visual observation. From there, it gets highly theoretical and
that's not even true. We can't see anything that's smaller than the wavelength of visible light. Okay, that happens at a far greater scale than the atom.
What I'm confused about is the way in which Lemonbird worded his Copernican theory stuff as if Copernicus came up with his idea overnight. He spent over 40 years observing things in the sky, celestial bodies' movements, and he didn't even want to publish his book, but was convinced to by a Franciscan monk.
The irony of this whole thing.
To publish something that went against the Bible, flat and dome cosmology. Jesuits, as we all know, are crypto Satanists at the top of their structure.
Fucking monks.
I think those are both philosophically good points.
After 40
Please,
years
14 more people talk all at once, and it might. Leo.
You're just color commentating, but listen, there was a disagreement about. Lemon said the thing about the electron center and the cloud around it, which I'm familiar at least with those common pictures. But then there was a disagreement, I think, from Charlie. Are you saying we could see deeper than Lemon was saying? Not as deep. What did you disagree with about what Lemon said?
Me?
John, please,
or whoever disagreed.
I said that even though we can't, it's not that we can't see it. There's actually a lot more stuff that's bigger that we can't see. We have a theory of the subatomic. Okay, it's called quantum mechanics. More generalized than that, it's called quantum field theory.
But are you agreeing with Lemon or not?
Who's Lemon?
The person who you were. Oh man.
You mean UN Assembly?
Yeah.
No, I don't agree with that person.
Okay, so do you think
if you were following the conversation, Don, if you were following the conversation, you would have known that he didn't agree with him.
Listen, I heard that he didn't agree. I'm trying to rehash and go over why, but thank you, Patrick. Sir, I heard that you kind of didn't agree.
Interrupt what I was saying to do that.
I didn't. I said you had a good philosophical point. Lemon retorted it.
I wasn't philosophizing. Don, I was not philosophizing. I was just stating fact.
Honestly, Leo,
Stop, Don. Leo, I'm gonna correct this because he didn't interrupt you. You actually stopped talking. Two people actually started to talk at this, and then you fucking waffled on through it. So he didn't interrupt you. Don, shut the fuck up. I don't need your help.
You're so weird. You're so weird. Okay, so anyway,
I'm not. I don't need you. I don't need your support.
Oh my God!
To tell him that he is wrong.
Science with the guy. Shut up. So,
no, I don't have to. You don't get to dictate conversations in here.
You're right. I'm sorry, everybody. Sorry. Okay, let's rise above.
No, seriously,
but,
let's go.
Yeah, the thing is, the thing that Lemon said, usually that's the thing in content. Usually the flat earthers don't even want to buy that. And then it sounded like you were not agreeing with Lemon in the center of the atom and the electron shell or whatever. You were saying, you know what, even that is bullshit. We can't even see that deep. Or maybe I'm mishearing you. I just want you to clarify your
Yes. Yeah, I thought you just said that you heard him and understood.
Listen, it was messy. I wanted to get clarification.
So you didn't hear him and you
totally
didn't understand.
I did not know. You're correct. I did not totally understand.
Okay, well, just because you got this ego, don't say I heard him and understand. I just want to clarify. If you heard him and you understood, then you shouldn't have needed that.
Yeah, it's no big deal. Did he leave? I guess. Right. Anyway, we'll do some more later, man. I gotta take a break.
Now that he's derailed everything. Now, Charlie, I don't know how long you've been doing this, but for an apparent noob,
dude, he's not here.
Oh shit! Well, for an apparent noob, he does a pretty good job. It takes some people quite a while to learn all the stupidity to be able to converse at the level of the retard.
Well, the main thing is we're trying to think freely, and the blue pill sheep like you and others have a violent reaction against anybody who tries to leave the herd. So now we have to fight not only the corrupt establishment, but you as well. But you are not the enemy. You are just the programmed NPC sheep who think what you're told. So we have to keep our eye on the ball and keep focused on the truth and forget about the NPC Matrix warriors fighting for a corrupt system without knowing what the hell they're doing.
No, that's okay, but I want to address it directly. Dude, you're not saying anything original. You haven't come up with a thought of your own. Every one of your thoughts is somebody else's fucking rhetoric. You've posted the videos where you've repeated this bullshit, so stop pretending like you're some innovator of free thought. You're the sheep.
So what we're dealing with is the blue pill hatred of individuality, freedom of thought, daring to go against the system. The blue pill programmed NPC's intrinsic hatred of anybody who's willing to leave the herd.
Who is hating you because you're the one that slung a bunch of insults and repeated what you said, even though I had a clear, coherent thought and expressed, my thought clearly to you, and you just repeated the same fucking thing. Not an original thought, Lemon.
So let's explore this flat Earth thing and see how deep the rabbit hole goes.
There you go. Don't address what I said. Let's just derail while insulting. There you go.
And there's no rabbit hole to explore because every time we bring up a model, you flat earthers reject it. So how are we supposed to talk about what's on the flat Earth if you guys have no model?
North Pole in the center with the continents radiating out seems pretty good to me.
So are you saying you accept Gleason as a model? The
Gleason
map?
or AE is the closest thing, yeah.
So either you accept it or you don't. It can't be the closest thing. It has to be what you believe or what you don't believe.
Well, no,
I accept it. How about you?
The thing, no, because I've actually traveled.
I mean, how high is the dome? Do you know?
About 100 miles up, give or take.
How many miles?
About 100 miles up.
So the sun is outside the dome or inside the dome?
According to the Bible, it's within the dome. Whether the dome is multi-layered or there's a pen light shown on the dome from beyond, that I guess would be the question. But the Bible says the sun, moon, and stars are within the firmament, or set in the firmament, rather.
If the dome is at a maximum of 100 miles away, why does it not get smaller as it moves away?
We've seen video of its changing size with and without a filter, so we're covered on that.
No, you haven't.
That's wrong. That's absolutely wrong.
That's absolutely right.
No, it's not. It's not right because you say it is, and it is, and you can't get past this.
Let me see if I can show you a video for you, or if the sun changing size. I think you guys normally say it's atmospheric, so you need to put a filter on it. I show a low quality filter by every day. Ignore that. So I guess I'll
every hour of every day.
2 times, but after that, I'm done.
9 billion people should be seeing this every single day. This shouldn't be a rare, special occurrence thing. This should be seen constantly, every day.
I guess it would depend on your position and how close you are to the sun as it circles over the flat plane.
You're going to be the position over time. It's no more than 100 miles away.
Steel City, you gotta do a little bit better. Try not to interrupt. You too, Chris.
Correct me if I'm wrong. You just interrupted me. Correct me if I'm wrong, Lemon Bird. But the sun is 3 to 10,000 miles, and last time I checked, 3 to 10,000 miles is a lot more than 100 miles.
So the dome would have to be pretty big, or it's closer than we think. If I go with the dome being 100 miles away, based off of Elf's sprite, another activity that appears to be something like electricity going off of a surface. They say it begins about 100 kilometers up. Perhaps the sun is even closer, but just has a magnified aspect because of atmospherics. It only triangulates to that distance because of a magnified image or whatever. But who knows?
I am just saying what you've stated.
No answers.
Is that you believe the sun is 3 to 10,000 miles in between there, and it travels between those two, or travels between those heights throughout the year. But the dome's 100 miles, so it's at least a minimum of 2,900 miles above the dome.
So, based off of the track record of the heliocentrists, it took them 2 to 3 centuries to go from 3 million miles away to 93 million miles away. That's a hell of a range. So, I guess we'll need a little bit of time to work this out, see if the sun's magnified or whatever. But without the Earth moving millions of miles through space, your triangle for triangulation of where the sun is gets much smaller.
No. I'm just bringing out a point here.
Just say don't.
Miles. Is a dome at least 2,900 miles tall? It may start at 100 miles, but is it how big is the dome? Not
how thick is it? I don't know. We could only see where it starts based off of elves and sprites about 100 miles up. That's it.
Okay, so if the sun's at minimum 2,900 miles above that, it has to be at least 2,900 miles high, right?
You'd assume if the sun's image isn't being magnified by atmospherics, yeah.
Well, I'm just asking you questions. I'm not assuming anything.
The sun appears to be about 32 miles in diameter based off of the time it took sailors to get out from under it, to go from a Lahaina noon shadow where there's no shadow right under the sun, they assumed, to when they started to get a shadow. That was about 32 miles for them, so looks like the sun's around 32 miles-ish. and about 3 to 10,000 miles up based off triangulation. But we'd have to look into this.
3 to 10 all the way, you just said 100.
Wait, what is the
Because
sun?
who
The
knows?
firmament's 100 miles up. The sun triangulates to 3 to 10,000 miles away.
Wait a minute. If the whole United States is lit up by the sun, and the whole United States is 3,000 miles wide, how is the sun less than that and able to light it all up?
Who knows?
What's going on, guys? How y'all
Did
doing?
you hear my question, Lemon Bird?
See if I can answer it in a way that you can process. Ask it one more time. I'll try to be more specific. Go again.
I think you dropped out right as I was asking the question, and I don't follow you for that because sometimes. All right, so here's the question: if the United States is about 3,000 miles across, the sun's only 28 miles across, how does it light up the entire United States?
One small light, Leo, can light up a very big room. It just depends on the magnification and the illumination power of the light. So that could still be covered.
How does that 28-mile sun then light up half the entire world?
Leo, at this point, I expect you to answer the question yourself when you look at a small lamp in a big room and analogize that for a small sun with a big surface. If you cannot do that mentally, I don't know what to tell you. A small light can light up a huge area, Leo. With the magnification through the dome and the focusing power of the dome, who knows what else is possible as well.
Well, wait a minute.
Is that good enough for you, or is there something that you didn't understand still?
No, I'm fine. If the dome is magnifying the sun, then why?
Oh my God, Leo! Really, you're gonna think that a light bulb is scaled to the size of the room as the Earth is to the, or the sun is to the Earth, or the entirety of our solar system? Really, you're gonna go, okay, that's fine.
No, I'm not saying
Chris, there's
a scale model. If we want to go with scale, let's get a light that's 1/100th the size of the room for the 30 to 3,000 mile ratio or whatever, and see if it lights up.
I'm just
accordingly.
Getting stuff clarified. I'm not necessarily believing what you're saying, but
Well,
here's the
that's
question.
fine. But you were like, oh, I was fine with that.
Chris, there's a better.
Statement?
Yeah, finish your statement, Chris.
The
But
dome is
then
magnifying the sun through. If the sun is being magnified through the dome, why is it not magnifying all the entire Earth and choosing what to magnify? That doesn't make any sense, Lemon.
That would make sense if it's a local spotlight. Now, if you ever have a flashlight, Leo, close to the floor, notice how there's a zone of darkness beyond that flashlight that's close to the floor. What I imagine occurs is we're so damn close to the floor, Leo, the sun has disappeared beyond the diffraction limit over the flat surface, and you're in a zone of darkness while the sun is way beyond over the flat plane. That's what I would assume is happening based off of a flashlight on a floor.
Illumination plays lullaby music.
Notice you can still see the goddamn flashlight, the source of the light, when you're outside the circle of illumination. Pay attention to that. And
you're exactly
with that. Quit fucking with this clown.
You're in the not on the floor. It's in the sky, 3,000 miles above me.
yeah, Chris, Leo, hold on a second, man, because Lemon has said a couple things actually. You could argue instead of whatever, just argue. But he said something about the sailors, 32 miles, and the subsolar point, and the fact that there was no shadow and they had to travel 32 miles, in order to see a shadow again. Whatever story that is. Regardless, if that story is true, and they were able to outpace the sun somehow, that still tells you more about the shape of the Earth and less about the size of the sun. Just because the sun is a certain size doesn't mean that being right underneath it is where you're going to get a no shadow, and you're going to get other shadows elsewhere. Whereas at 32 miles, it sounds a lot like half a degree of the Earth. That's 69 miles. So it's that fact that you said, Lemon, it tells a lot more about the size of the Earth and less about the size of the sun.
To quickly address the you're close to the ground in darkness, so you can't see the sun. That's false. Even if you perform this experiment with the flashlight, you will have a zone. You'll have a circle of light on a particular place, and if you put yourself in the position of the darkness, you can still see the object casting its light. Even though the light is not being shown or shined on you, you could still see the source of the light. That never disappears on a flat plane anyways.
Well, the fact of the matter is the sun's not at the floor. The sun's 3,000 miles above the floor. So
right, there's always
equating the sun to being at the floor doesn't make any sense.
No, and that's fine, but there's always, on a flat plane, there's always a positive angle to that source, being the sun. So there's always a positive angle to where you can see this source of light. And you do always see it, even if you're in the darkness and not in the area of light, you can still see the light source. You should be able to, if we're on a flat Earth.
This is why, Lemon, I don't know why you tried to build a model for these guys when they ask you questions on purpose about the model, knowing that whatever answer you give, they will have an answer because they say they can model it. So they're saying, well, if you model what you're saying, we can see the source of the lie, and that doesn't work. But so we have to go on and further and deeper, and that's basically what they're doing, is trying to build a straw man. So Chris knows what he's doing. Wants a model. Glowbirth is one a model, really so they will come at any angle, try and get you to build them a model. Basically, that's what we're dealing with.
When he presents false information, and then he's presented with correct information, it's not a straw man.
Yeah,
it's
you're always
addressing
going to be able to
his
say
mistakes.
that doesn't work on the model. It doesn't work.
Right. It doesn't work.
Yeah, exactly. So I'm saying that Chris does it on purpose. Ask Lemon to build him a model, and then whatever Lemon says, you can say, wow, that doesn't work on the model.
Well, no. What he's showcasing is he's asking for Lemon's explanation. When Lemon
on the
gives
model,
an
yes.
Hold on, Kima, hold on. Lemon gives an explanation, and then Lael or someone else is explaining the mistakes behind that explanation.
Yeah.
If they're mistakes, they're mistakes. It's not a matter of a model.
Yes, it is.
Lemon's point of view and explanations are incorrect based on the reasons that people explain.
Because you've modeled it already.
The model is inconsistent because you'd expect half day, half night all throughout the planet. You wouldn't expect varying days of sunlight. That's not explained in your model. That's better explained with a local spot of the sun migrating over the surface. So your model itself has holes that are glossed over because of bias and preference for it. And so as a person with a differing view, it's my job to point them out and point the way possibly to another model instead that might be flat and covered by a dome.
Great. And answer the question about you giving the example of a flashlight on the ground, but the sun is 3,000 miles off the surface of the ground, so you can't compare those two things.
That's what we do when we're above the light source, Leo. When we're close to the ground, we would be in that dark zone beyond the light and not see the light source because we're too close to the surface. The refraction limit would make the object merge into the surface, and we wouldn't see beyond the horizon in the foreground.
Inadequate explanation. And what you just said about half of the Earth and all that, that was utter bullshit, Lemon. What we have is what we have. What you described is not what we have. Nice lying there, Lemon, and you know better.
Well, the thing is, the Globers, like myself and others before I went flat, have an inconsistent view of perspective. They don't take into account the diffraction limit that makes parts of the visual scene disappear and become unresolvable. So if you're 6 feet off the ground, you can only logically expect 6 feet symmetrical convergence
everywhere,
for 6 feet up, down, and left, right from the level of the eyes.
Dude, learn to wrap it up. You're just fucking droning on like nobody's business, saying nothing but lies.
I'm not processing what I say, Curved. I have to get it out over you for the audience who might be listening.
And I'm quickly refuting it, Lemon.
Lemon, there's another issue with your proposed explanation. So even if it were to disappear, it wouldn't, obviously. But even if it were to disappear, that source of light would go from being a circle when it's directly above you, let's say at noon, and as it moves away from you, it would become more oval and eclipsed until it disappears that way. What we witness is a essentially perfectly circular sun from sunrise to sunset. It never changes shape. Your explanation dictates that it would
got
change
you
shape.
covered on that too. They showed a sun-filtered sun going away, and it turned into more like an oblong disc. Out would come the globe excuses saying that it's refraction as opposed to something perspective related. So we're covered on that too. Maybe we need to look at this from another perspective.
Do we
That
need to
doesn't
bring up
happen every
videos?
day. If it were perspective, that would happen every day.
Right. Do we have to bring up videos? Because in your explanation, it would happen 100% of the time. In the globe model, there is room for refraction to do things, but the most common event is a perfectly circular sun from sunrise to sunset. There will be occasions where it's different, but on the flat Earth, in your explanation, it would happen 100% of the time.
Perspective
Well,
would
that
also
doesn't
be a
follow.
gradual
There are people that
change,
show that
not suddenly doing that when it gets near the horizon.
But people show things disappearing bottom up, and the sun appears to be doing that over a flat plane as well. You're just too close to the surface to get even symmetrical disappearance on the object, because you would like even room on all sides of the vanishing point of the object, but that can't be expected if you're 6 feet off of the floor and the object is way high in the air with infinite room from the level of the eyes up where the vanishing point is.
Hold on. The sun disappears when you're miles and miles above the surface of the Earth. Don't give me this close to the surface of the Earth bullshit.
But it goes away and disappears more evenly the higher up you get.
No.
You get the most even disappearance. And the object is centered in your field of view with half of it above the level of the eyes and half of it below.
Demonstrate your lie. Support that.
Support that? That would be supported since we have a vanishing point on the object that demands equal room on all sides for it to vanish evenly.
I said demonstrate it. Show it. Support what you just said. What you just lied.
Saying it logically with words, but you can't process it. And I'm way too lazy to write out a diagram right now, so I'm sorry. I don't know what to tell you.
Yeah, keep lying for
Well, then go
Jesus.
find a photo.
Keep playing with this cunt.
Lemon, you ignored exactly what the point was. It had nothing to do with it disappearing from the bottom up.
Repeat the freaking point, or I'm going to deem what you say unimportant.
It was the shape. It maintained circular shape.
How did I respond? I said there is a solar filtered video of the sun where it looks like it's becoming a disk. So we're covered with that too. You countered by saying we should see it all the time. That does not necessarily follow.
Explain yourself,
dude. And if it's above our heads and the disk is facing the Earth, yeah, at only one point in time would it ever look like a complete circle as opposed to.
Now, who's got an inconsistent idea of perspective? Why would it not do the same thing every evening or every sunrise?
Spheres are the only shape that maintain in perspective.
And not only that,
Because
it's not even
spirits and us being way
the,
too close to the surface.
No. We're not even talking about the horizon. It would be a perfect circle at noon. That'd be the only time. And as soon as it deviates from noon, it would start to it would approach the oval shape. So your example is at extreme horizon during different conditions. But you would see it at every point that it's not noon. You would see it change shape.
And it doesn't do that, Lemon. It doesn't change shape like that.
Right. I posted a video, a number of solar filters at sunset. Can you take a screenshot when it's this extreme oval shape rather than the horizon physically obstructing it?
For me, Lemon, this is just their sneaky way of getting us to build a model because they can't figure it out for themselves.
No, it isn't. Dude, Chemo, he's just describing the Earth as he thinks it is.
No, you're telling him how does this work. You're asking him how does this work. Explain this on a model.
That he didn't say. No one said.
No, not on a model.
Explaining how it works. Period.
Right.
Isn't the same as can you put this on a model?
Yeah, he can explain it, but you'd want it modeling.
No, wait a second. We don't ask for a model because we don't know how to do it. We are demonstrating to you that it cannot be done if you would ever attempt to do it.
So you
That
can't
is
do
the
it.
point. No one can.
Exactly. So why are you trying to make a model? Just said it. No one can model it. That's the point.
Because it's not.
Duh. It means you don't know how to model it.
Try to model, it will be wrong.
Watch, here's a really simple observation.
We're saying in reality, measurements show that it's not curving. You can't model a non-curving surface.
You're an incorrigible liar.
Yeah, you can't model a non-curving surface, so you have to use a globe model. Now you're asking Lemon, how does this work on a flat Earth? We don't know. We don't have a model.
You can model flat surfaces.
We don't expect the model.
Yeah, so anything you ask is how the sun works. Any explanation Lemon gives is going to have to model it.
No, he doesn't. You have to model perspective, and the thing is, perspective, like symmetry, in equal room on all sides. That's impossible if you're only 6 feet off the surface. You'd have at best 6 feet on all sides up to a point, and then limitless room beyond, where the image continue to crush into the surface. And so this, there's actual observations here that are forgotten.
I mean, there's several people who are trying to respond to Chemo. Just 1 second. Very briefly, I'm just going to tell you, Chemo, when you tell us that you have an idea of the way the world works and you are discounting the way we say the world works, the one that we have already modeled, then that's not our requirement to come up with the model for the way you think the world works. That doesn't make any sense.
That's what
doesn't make sense for the people that you're disagreeing with to come up with your idea.
For a replacement. We don't have to replace it because we falsified it.
That's not a.
That's fine.
Well, we can come up with something. I mean, but we need consistent principles to model it. The thing is, the Globers try to model flatness, but their principles are a little inconsistent.
They're not smart enough to model flat Earth.
Says the guy that the sun sometimes is oval and sometimes isn't by perspective.
They take a flat level plane and change it into a ball. That's not modeling where we live.
Every time we try to get a flat earther to be consistent, they're inconsistent. So how can we develop anything if they're so inconsistent about what they say?
And actually, Chemo, there are a lot of flat earthers that don't hold that same position. There are plenty that attempt to model flat Earth.
Yeah, they attempt it. That's right. But you know that it
explain
cannot
the
be
world
modeled.
that they see in the terms of a flat Earth. Most of it
Before you could build a model, you have to have explanations for things. If those explanations are false or wrong, you can never move on to modeling. So when Lemon provides an explanation for something and it's wrong, we're not expecting a model. You can't build a model with wrong explanations.
Well, if
so
you model
once he has the correct
model perspective onto a surface except the flat plane. That's what we see with the flat horizon. We don't see a curve. We're trying to mix perspective and the ball together, and it's just not working.
What you see is not a model.
There never will be a flat Earth model.
Necessarily reality. So we need to
Hey,
see
quick,
what's
someone clip
disappearing
that.
and being cut off early over a flat plane.
Why do you keep saying flat plane?
Because this is 500 years of indoctrination and conditioning that needs to be broken overnight.
You don't have to answer that.
That doesn't tell me why you call it flat plane.
Okay, come on, dude. That's
disappearing over a flat plane.
Okay, fair enough. Chemo said something that can actually be addressed. He said they're never gonna have a flat Earth model. Okay, why do you say that, Chemo? Why do you say that you're never gonna have an explanation
Because
for the way
you
the world
won't
works?
accept the calculations for the light bending. You can't calculate what should be seen, how the sun works. You can't explain how the sky works. So unless you accept these things like Walter Bisons has put forward, you'll never have a model.
I wouldn't project like that, Chemo.
Yeah, then how do we know that the eclipse is happening at like 10 a.m. your time?
You already presuppose the shadow is the Earth, so...
Why would it be the Earth when the moon's going in front of the sun, you twat?
On a lunar eclipse.
It's a solar eclipse, you idiot.
Yes, but we're talking about the lunar eclipse, where you presuppose the Earth's shadow.
Oh, no, that's in the past. That's in the past, man. Stop living in the past. Get to the future.
The one in morning is a solar eclipse.
Anyway, the point is that you don't like how it calculates and models. You don't like Walter Bisling's model. You think the light doesn't bend like that. So
what?
Where'd you go from there?
What do you mean we don't like Walter Bisling's model? We use his calculator all the fucking time.
He meant the flat Earth model that Walter Bisling made. But Chemo, you said that there will never be a flat Earth
unless you accept
model. Right. No. You didn't say unless. So I'm not saying what people will accept. I'm saying what you guys can produce. Pretend nobody accepts it, but you guys have it. You guys can look at it. And you guys can accept it.
Well, again, Lemon could model what he's just said, but you wouldn't accept it.
It's not about what we would accept, dude. It's about what you guys would accept or what you guys could create. Why do you claim that there would never be a flat Earth model, a description of the world as a flat Earth, ever?
Because your model is a predictive model. Okay, so you want to be able to make predictions and calculations, and because of the way the atmosphere works, you cannot calculate these.
No, that's a misnomer. Hang on, that's a misnomer. You just said we have a model that predicts shit, and you're saying it can't work, even though it predicts shit.
You want a predictive model, is what you want.
Yes, and if you don't have a predictive model, what's the point in having the model if you can't work from it to work out weather patterns, how a plane's going to get from point A to point B?
Right, so any explanation of flat Earth it gives, they could model it, and you would say it doesn't work.
Not explanations.
Let's pretend it's not a complete model. Let's pretend that you don't have to model every single thing like the atmosphere or this or that. Let's just say it was the simplest model you could possibly have, and it was a geographical
Could you model the
where
globe?
The land masses, where the land masses were.
Could you model the heliocentric without knowing the size of the Earth?
Chemo, where the land masses are. So what if that's the only thing that you required in your model? Was where the land masses are, how far away everything is, and it was basically like a map.
Yeah, the flat Earthers haven't explored the flat Earth to know the size and the shape and the locations of countries, right?
I'm pretty sure that Lemon agrees that the United States is about 3,000 miles across and 1,500 miles north to south. So, I mean, that's a pretty big area of knowledge of how big a country is.
And I mean, you're lucky that Lemon does it. I mean, it's just to appease you guys, really, because, you know, you want a model, you know it's not a globe, you want to know how it works on the flat Earth, and Lemon tries to work with you, but whatever he says, you're going to say, well, that doesn't work, we can't model that. So...
Alright, so can you help me understand what you mean by model? Because if I ask a question, like how big is the United States, and he answers, can I start developing a model that represents that distance?
Well, ask Lemon, I don't know.
I'm asking you, what do you mean by model?
Predictive model is what you're looking for, right?
Like, for example, Chemo, how big across do you accept that the United Kingdom is? From east to west.
Not about what I accept. I mean, again, if that's what they say it is, that's what they say it is. Unless I go out there and test it, then, you know, it's not in contention. What's in contention is the curvature.
Wait, hang on. How can you say one thing's not in contention, but then contend all the other stuff that goes with that thing?
Curvature. That's it. The Earth does not curve. You say it does. Where are the measurements?
Do you have evidence of that?
Well, Leo's question implies that he wants distances. So based off of Captain Cook and others clocking 60,000 miles around Antarctica, that means that it's roughly 20,000 miles across if we assume something circular.
Okay. I'm not assuming
let's get back to the point of contention. To contend something, you need something to measure against.
What's up, flat power?
Not Chemo, Leo, what else do you need to know? The distance across appears to be roughly 20,000 up to that point anyway.
So you would agree that the United States is about 3,000 miles across?
We can still take those
East to west.
distances and glom them onto a flat map. They don't need to necessarily change. The only distances that need to change are the ones that are calculated based off the Haversine formula and the global assumption, as opposed to a hard, physical, reliable operation. So some of these we can transport. Some of them we might need to test.
I don't disagree with you that we can definitely say that the United States is a certain distance, and then we can also say, since people have flown from the United States to, let's say, Japan, that we know that distance too. And we can develop, based off your agreement that the United States is so far across, and that it is so far across from LA to Japan, that the distance of the circumference of the circle, whether it's a sphere or a flat circle, is a certain circumference. Do you agree? We can build a model off of that.
Yeah, the only place where I disagree is we need to see if they're going in a straight line across the pizza and or being blown in a curved path over the pizza. We can't really tell either way if we're sailing. Now, for flying, it's probably more of a straightish path, probably, but jet streams are a thing. So, I mean, how can we know what the exact path is over whatever shape we talk about? That's where the rubber meets the road. But I agree with you, Leal, yes. I agree with you.
Can't you determine it based on the distance, the time it takes you to get?
Oh, sorry, Kosho.
No, I'm just saying that can't you determine if it's a straight path or a curved path by determining the length of time it takes to get there?
You have to assume that they went in a straight path. How can you make that assumption over long distances without a straight line string or some sort of referent? We would have to assume a straight path. That may or may not be the case, especially if you're in a ship that's tossing and turning on the sea.
Lemon Bird, would you accept the distances that flights give from one destination to another?
I accept that we're on some sort of circular thing, be it a globe or a flat pizza, because the sun regularly comes back. The only cyclical motion that we know of that returns like that is a circle. So I'm quite comfortable with some sort of flat circle with the continents probably radiating out from the north. That's all.
Okay, so are you comfortable with the distances that planes or flights give from one destination to another, like LA to Tokyo?
Roughly, yes. I would tend to distrust them in the southern hemisphere because there appears to be more land down there, and they appear to have to cut through the central north to cut down on time and distance. But yes.
All right, let's talk
and
about...
also, Chris, one other point quickly is that the cabling, the wires that go from South Africa to Australia, the cables go north, but it's quicker to go under the board, the cabling, but they send the wires up just like the flights and then down. Doesn't make sense, Chris, on a flat
cables. Anyways,
the undersea
cables, yeah.
They tend to snake around the continent. So another thing with those boats, Leo, is whether or not the boats are following currents that are snaking around the continents and or going straight across the water. So this stuff can get a little complicated.
Okay.
I want to ask this question then.
Get in, Leo, quick.
Okay, so Lemon Bird. Let's say you have a city at 0 degrees latitude. So you're on the equator and you're traveling to another city in another country at 0 degrees latitude, let's say somewhere in Africa. Would you accept those distances?
Well, the sun would be circling overhead, but I guess I'd accept that, yeah.
Talking about flying in an airplane, who cares about the sun?
Right. I guess we could accept that. If it's over land, I would accept the land distances. I would assume that they're superimposed onto a general sea schema because of the impossibility of getting a straight line on the bobbing and undulating ocean.
Perfect. Okay. So if we can accept the distances flown and add those distances up, and we can determine the circumference around the equator, would you accept that?
expanding ever outward toward the Antarctic ice ring.
I'm talking about just the circumference of the equator, nothing else.
Sure.
Would you accept the flight plans and the distances they say around that circumference?
Guys, how many times do I have to say yes? It really stalls the conversation to say yes.
Chris Lael, yeah. Chris, I feel like you're taking. I feel like you're taking a long time to get to wherever it is you're going, Chris. I don't think
if those take up to 20, if those add up to 25,000, would you accept that the?
For the fourth time, yes.
Okay. The fact of the matter is they do add up to about 25,000 miles. And so the circumference of the equator is 25,000 miles.
All right, so what about the circumference of the Antarctic ice ring? The land beyond the equator, how about that?
Well, we can do the same thing for those and show that it's not the same distance. It's actually a shorter distance the lower you go past the equator.
Not according to sailors in Rowbotham's day. They said we're getting way too much land down here. Way too much.
So you accept the plane flights on the equator, but if it's south of the equator, all of a sudden they're not right.
Well, Leo, we did say that the planes appear to deviate toward the north to capitalize off of the smaller amount of land toward the inner part of the pizza. You did hear that and process that, right? So we need to see what path they're actually taking.
They head north, Chris.
I did hear and I processed it, but I don't accept that as true.
Okay, then we need to see figure this crap out. We need to see what path it's taking over a flat or round ball. But ideally, we could get a flight to flight on the same, latitude without a northern deviation, ideally. And maybe then we could start to figure some stuff out.
Flight from one side of Australia to the other side, showing that it's actually 2.5 times less distance than it shows on that AE map.
I guess we could look at that. The main thing is the oceans, Leo, because of the impossibility of getting a straight line on the sea. That appears to be where most of the extra quote-unquote land is being clocked in. How do you draw a straight line at sea, Leo? How?
You don't trust lasers.
Flying from one part of Australia to another part.
You're still on Australia. Yes, Leo, yes.
Perfect. So if the landmass of Australia, and what does the ocean have why would it be any different? Because if you flew the same distance across Australia as you fly over the ocean and turn around and come back, it's still the same distance.
We're dealing with circumference. It appears that in the southern hemisphere, they go toward the north and don't go in the southern hemisphere with a southern hemisphere circumference. That's the main thing that's in contention.
Heading north, Chris, like the wires and the aeroplanes.
Chris, let's let some better fools get some questions into.
Well, hold on. How does Chris answer
just
that?
I know people wanted to ask.
Yeah, before that though, let him respond to Lemon now. Chris, how do you explain they're going north?
Lemon didn't say anything.
Yes, we want to know about going north.
Well, all I have to say is a plane flying from Johannesburg to, let's say, New Zealand doesn't have to fly across the equator. It just flies to New Zealand.
Okay, they have to be relatively close to each other. How about longer distances, like Australia to South America? Do they make northern deviations that are a bit more explicable on a flat pizza, cutting through the central section?
Well, if you're talking about southern flights from southern Australia to the southern parts of South America,
Africa.
they would not cross the equator. They
Would
may deviate a little north,
or
but they
do
would
not
never cross the equator.
That's very different, because some of these flights appear to have inexplicable northern deviations, which are a bit more straight line-ish on a flat pizza.
I want to save fuel, not use more.
I just stated clearly that they deviate north, but not north enough to go across the equator, Lemonbird.
Really?
They don't even really deviate north. I'm just saying if they do deviate north, if they do, I'm just saying that if they do deviate north, they don't cross the equator. They don't fly 3,000 miles out of their way to cross the equator to then dip back down and hit southern South America.
What is the path of a flight from Sydney to Santiago?
Got to go over the North Pole way, Chris, right?
When I tried to chart it on those airplane Expedia services, if you got the flights that had layovers, they appeared to make straightish lines where they'd go to places like Dubai, India, which appears to be north of those locations. Then it would stop over in like Texas or something like that, and then it would go to like South America. It basically would make more of a straightish line over a pizza. If you have
find the direct flights then. And
well, that depends on whether the straight flights are available and are actually a thing, or if they're just printing them to save face.
Wait a minute. Find those and then compare the total flight time to your ones that go north. See which one's
those
longer.
flights, Lemon, are supposed to exist, and what they do is they have a heat-resistant paint that can make them fly faster, like this.
A heat-resistant paint that makes them fly faster.
Yeah, some kind of coating.
Is it true that red race cars move faster?
No, they're supposed to have some coating to stop the planes, overheating.
Sounds about right. I think red cars would go faster.
Hey, the red color means they're moving away from you because of the red shift.
Boom.
I'm sure that's Warhammer 40k logic.
What about the white ones?
I want to point out to Lemon, I just did a thing on Google Maps where I went from Sydney to Santiago. And guess what, Lemon Bird? That flight path is actually deviates south, not north. It does not cross the equator. In fact, it goes closer to Antarctica, according to our mapping.
Greater Circle route.
It actually flies over New Zealand if you actually look properly. Goes over the North Island there.
You're correct.
Everyone knows New Zealand isn't real.
Hang on. I've got evidence of a conspiracy about New Zealand, though.
It's got to do with farms. I don't care.
Well, I have evidence. That England doesn't exist. You know why? Because tea comes from France.
How rude.
There you go. There's my English conspiracy for New Zealand.
I like that. That's good.
Teletubbies filmed in England.